Okay, let's get started with Objective-C programming for today. Today's fun. Actually, we're going to look at views as a concept from a programming perspective, and then we'll do a little tutorial, just one today, on choosing with sliders and views and data. So working with different data types, translating one data type to another data type, because this is the Objective-C course, and we're focusing on programming. And then we'll get into a couple of other subtopics as well. But let me, this is a Microsoft, this is a PDF file, so I can't have to scroll through it. So, what we're going to look at is the difference between UI and NS. So next step in UI, one of them is for the Mac OS X, or someone keeps reminding me it's OS 10, okay. I like to call it OS X, but anyway, I might be the only one. One's for the Mac desktop system, and the other one's for the iOS system. UI is iOS, NS is Mac, so for the desktop system. And if you happen to know that actually the system is the same, it's just translated over into different hierarchies, slightly different hierarchies, and a few different components. So NS view, as we've seen it so far from the iPhone class, actually, it's the view. It's not the window, it's the view. So it handles drawing and events from the rectangle in the window. So we can put many different views inside, and we can switch views back and forth inside of the window. Buttons are text fields that are NS views. So from the hierarchy, everything that goes inside of the view is from the same hierarchy. So if you remember that introspect, I don't know if we did it in this class or the other one, where we looked at the components. We kind of went through each one of the items that was out there blindly to see what it was and check to see. Because they're all of the same subclass, we can go through them like an array, because we can all reduce them down to components, or to objects, I should say, and then figure out, are you a label? Are you a button? You know, what are you? And so a view can contain subviews as well. And the subviews is the NS view to implement your own drawing and event handling. So here's our view hierarchy. So this is for a Mac platform. We'll look at the iOS in a few minutes. But here we have the NS window, and then inside we have the NS view, and we have a text box inside of the view. This is where we're getting the window, context view, box. These are the objects. And these are the messages that we're sending to say, from context view, give me the subview. Give me the context view. So we see this a lot in the iOS development as well. It's the hierarchy that we're working with. And so the NS window leads to the view. And you could put something here, you can put multiple subviews in there too. And our box, or a text field, as we're going to say it. So these, don't worry about the object naming convention right now. This is for the OS system. Some people develop for that, so you might be interested in knowing it. So, but it's just a matter of breaking out each one of the different components into sub-hierarchical components and putting them together. So bounds and frames. So NS view itself has two rectangulars associated with it, the bounds and the frame, which are going to be the components that you're going to be programming in terms of adding components to it, making it visible, exceeding it, or staying within the bounds of the window. So the frame is the view's rectangular inside of its subview. The bounds of the rectangle defines the coordinates used for drawing events inside of the view. You can actually write some OpenGL is what I'm thinking of, OpenGL, and actually use the bounds of the rectangle and draw stuff in there instead of using pre-built components. So instead of taking instances of objects that already exist and sticking them inside of a frame or inside of a view, or etc., you can actually draw your own stuff as well. So it's handy to know that there are the two concepts here, and here we have the bounds and frames in a little picture. So now this is the point 0, 0, which is on the lower left-hand side of the view. Excuse me, yeah. And then we have 40, 30 in this particular case, which is out here. So we can draw rectangulars. We can draw, in fact, here's kind of the Objective-C source code to kind of do it. Make rectangular for the frame and for the bounds, and then we're setting. This is the code here that defines this orientation, or this particular box in terms of the view. When you're going to do that, you'll actually see it all the time. Actually, when you have, let's say, a menu bar, like what we saw last week, actually, and we're going to stick something on the menu bar. Well, we can define how big we want it. in terms of the rectangle that we're going to stick it in. So we can declare the bounds of it to equal some orientation. Not to be confused with the concept of orientation, that's different, but yeah. So bounds and frames, changing the size of the bounds, scales by the coordinate. Here we have another way of presenting the same kind of concept again. Looking at the 0011 kind of concept, so some higher to lower extreme. So drawings. So we can actually draw without using, because right now we've been dragging and dropping and sticking stuff on the view. We can actually draw. So defining it in your NSView subclass, you can define draw rectangle, and then inside you could draw things inside of it, lines, points, triangles, things of that nature. So rec is the subrec of the bounds that needs to be redrawing. So so you're allowed to skip through everything inside of it. Don't call it yourself, it won't work. It gets called automatically by the window class when it's going to call the frame, and then the view is going to be added in there, so it'll be called automatically. In fact, we'll see that today with in the iOS class. We'll see it with the jigsaw puzzle. You find the, in fact, it's going to find coordinates, which is kind of interesting. So going back to this concept, there's a lot of things in which the coordinate system is actually used for, which is out of the programmer's control. As an example, if you touch on a screen, you can get the coordinate system and then move to another, move around or track it, or move objects around quite easily, which is what we're going to see later. So because today's all about drawing and stuff like that and views. Redrawing, you can't call draw rec directly, but you can do it through view. Set needs display, yes, or needs display in rectangle rec. Just tell Coco to redisplay the proper portion of the view. Why do you want to redisplay? Because you've changed something about it. So programmatically you can alter the view, change the view, and then redraw the view. You can't really call it though. It gets called automatically. And that's the same for the Coca and for the iOS Coca Touch environment as well. So, graphics. Let's see, NS bezel path. Collection of path elements, lines, segments, curves, used to represent boxes, circles, lines, arbitrary vectors, graphic shapes, many drawing operations for strokes, to fill in interior clips, stuff like that. So most people who get into this is just a brief introduction to the graphic packages. You're probably going to look at OpenGL as a library to extend basic graphic capabilities if you're going to get into this. What do I mean by get into this? You can spend your entire life developing apps and never touch OpenGL. It depends on what kind of apps you're developing. If you want to be able to draw, in fact, you mentioned earlier that app where you're putting your finger inside and you're coloring in numbers and stuff like that billboard they have on 101. You could probably take an OpenGL package for that and draw it in and get the orientation, because what you're going to be looking at is the grid and where the person is actually touching. But you can easily do it without, actually. A couple of different ways using touch control and touch begin, touch end, and things to actually draw a line or draw something. NSColor, we've seen NSColor a lot. We have a built-in predefined color set. Default colors here are from NSColor, red color, blue color, light blue, red. Nobody memorizes all of the built-in colors. You use them when you want to use them, but programmatically you're going to use them this way. You're going to basically figure out all of the colors ending with the word color. So it's going to be red color, blue color, orange color, black color. Make up your own color as well. And you can make up your own color using the red, green, and blue alpha scale, which is what we're going to see today, actually. So we're going to see red, green, and blue with sliders where we can adjust color on the graphic screen, and we can actually change the view background color to something programmatically by looking at the indicators, which is kind of interesting. So setting the color for the drawing, you can do a color set for a drawing, depending upon what color you've defined, which is going to essentially update the system. So here's an NSColor of blue, and here's a path setting out a rectangle with blue color set, and then you're using a set to actually present the color, and then a fill path to fill it in. And the path itself is the path with rectangle R, and R was defined or should be defined somewhere else in the code. R is not defined right here. But R would be this coordinate system. R would be something similar to this kind of path declaration here, but instead of doing it, we'd use a path that equaled something so we could draw it. So. And basically by drawing a rectangle, we would draw it with paths from one coordinate or location to another. And here's another one with a fill, so in its color yellow color set stroke, so put the yellow on the outside, but we didn't fill it, we stroked it, which means drawing a line instead of filling in the coordinate system. A little bit easier than working with OpenGL and also some C libraries if you have any experience doing that. It's a little less cryptic, I should say. There's more built-in libraries and functionalities and predefined sets. And here's the thickness, so you notice this is just a regular fill of 1 or 2 pixels or something, whatever the default value happens to be. And then the next one here, we're going to set the line width to 20. So you can see we're just basically calling the method call on NSColor to yellow color to set, which means fill in this graphic for the path. And path of the bezel, NS path is basically defining with this path with rectangle. So we have with path with circle, path with triangle, path with, however we have it actually specified for which one of the methods we're going to call on that object, sending it which kind of coordinate. And this would be the coordinate system that we're sending it. Convenience methods. Okay, so that's all really I have for you on color and graphics. We'll see a little bit more of it programmatically. It gets a little boring when you start going through too much. But not a bad idea to go and kind of revisit the concept of convenience methods, which are like constructors for convenience, so that you can fill a rectangle, stroke a line from one point to another point to create a line. And so these are class methods that you would run on to basically perform automated or more rudimentary stuff, but automated together. So here's a text for drawing. So we put a string inside of a drawing. So moving on to a kind of a slightly different tangent on this concept is if you were going to draw the screen manually, because what we're doing right now is looking at components that are not part of the GUI system. Because a lot of people want to just put a label out there or want to just paint the background to something. Here we have a string that we have defined here, a string. And we're going to draw the string at some arbitrary point that we've put out here. And we're going to make sure that the object itself, for the attributes for the object, are going to be red color, and then we have the foreground color attribute name specified for the key. So, and it's not the background, so we have the red showing up on the text that's on the box that we put in here. And this box came from nowhere; it's not in the definition. It could be this box up here from the previous example. We actually never really declared the box in the slide set. I'm just showing you kind of method examples for how you would achieve that. So here's the same thing as before, with instead of the text putting an image in the box. So image drawing itself. So defining the image. This we actually have done with UI image. Actually, we have done this. We did this with tic-tac-toe. Yeah, tic-tac-toe. We did this with tic-tac-toe actually. But in our tic-tac-toe game, we had UI image, not NS image, because we're on the iOS platform. It's the same concept, but we go NS image on the OS X platform. So NS image is going to be image name Bob. So I apparently have a image name Bob out there somewhere. And then the image is going to be at a draw point. Well, and it's 0 point from, and then specifying the coordinate system. And that's going to be the image size that we've specified, and we're going to put it at the location. So, and a composite copy. So, just means we're not going to transform it, we're not going to shade it or anything, or color it or anything. We're just going to copy the image into that location. So on the iPhone, as I mentioned before, UI view instead of NS view, UI color instead of NS color. Everything is UI instead of NS. No, this library doesn't exist, but we have OpenGL that's built in. Low-level C functions to make this happen, but it happens through OpenGL. So you'll see OpenGL is a project type, and you'll see it. Actually, we'll load one up when I get done with this. I'll kind of see what we're getting with that. So drawing is much slower. Try to avoid custom views if you can. It's a lot faster to do it using the built-in objects and the components that can garbage collect. So another theme for tonight are events that we're looking at. So the NS application. So this is not an iOS because we have NS here. This is for a Mac system. Manages the main run loop of your application. Waits for events. Well, we have a similar kind of concept that happens with the iOS app as well. Waits for events from the mouse, keyboard, other sources. Except for in iOS, we've got orientation, the event of moving the phone, shaking the phone, dropping the phone. Actually, you can pick up all of the motion censored events that happen in terms of positions of the phone, which is kind of interesting. Dispatches events to the relevant objects. In this case, the NS responder. Well, it's kind of the same thing. We get first responder as the event of the keyboard that actually shows up when we type in a text field. So it's the first event that responds to it is, hey, we want to do that. Owner of main.nib. Well, we still have nibs actually. We still have XIBs as well in the OS X environment as well. So the application lifecycle, we have this run loop, which is very similar to iOS. In fact, I don't know if it's in this lecture, but it will be. I think it probably is actually towards the end. Waiting for an event and then handling an event. So it's in the old days, you used to call it a state machine or an endless loop. So you load up the main screen or the main application window, and then it just sits there and waits, and then it responds to these events as the events occur. So some sort of input from the user, a mouse up, a mouse down, a mouse move, keyboard press, released, drawing tablet, events, drawing events, or something of that nature. And then on the Coca Touch, we have all the touch and the gestures that occur. So in a non-iOS environment on a Mac system, we're looking at the mouse, essentially, for the major input. So events that are dispatched by mouse events. So the window serves as an event for the NS application. Owns the window under the cursor. So wherever the window is, whichever is on top of the highest hierarchy of whatever got touched, is going to receive the event automatically. So in other platforms like Android system, actually, we have to put in event listeners. We don't have to put in event listeners there. It's done for us automatically. So in void send event, so now we can see sender. So the sender concept, what we see in iOS actually, where we see IB outlet or IB actions, and then on the outlet we receive an event via the sender, and we imply or we produce the action. So we have an IB outlet that's associated with an IB action. The IB action is what's going to happen when that event occurs. The sender, by default, is the named object. So people are, well, what do you mean by sender? It's kind of like object. Object is the highest level object for all of our components in the hierarchy. Well, sender is the highest level object for all of the events. So we have the send event, we have the receivers, senders, responders, which kind of all coordinate to the same kind of hierarchy of events. So here we have, and now when we look at the code today, I'll show you a sender, sender, resign first responder, which means the sender. What was the sender? It was the text box, or it was the label, or whatever it was that generated the event. Well, it didn't generate the event, the user generated it by using it somehow. So, okay, so in terms of the event, the application sends the event to the appropriate NS window, and then the window hits the appropriate view using a hit test on its context view. You don't really see that, it happens in the background, but we can get the context view and see what view is shown, what's out there. So depending upon the event type, we have methods that work with the NS view. Now we're on a Mac system here, and we're looking at, in this particular case, we're looking at the mouse. And we have mouse down, mouse up, mouse move, mouse exited. If you want the same corresponding for, this is for Coca. If you want Coca Touch, just take a button, a UI button, and right mouse click on it, and go through all the different events. In fact, the label of the category is called events. Touch down, touch up inside, touch up downside. All the different ways that you could possibly touch a button is also part of this as well. Not to be confused with gestures. I believe next week we'll be looking at gestures. This week we're looking at touches, touch events. The gestures are a little bit different because you're using multiple touches together. So it's patterns that are predefined as gestures, and then you're watching for certain gestures, and then on different gestures like a pinch or separate or 2 fingers up, 2 fingers down, a left to right, a swiping gesture. And then you can pick up those as a separate set. So they're different than single touches. So they're basically multiple fingers that are doing something in a pattern. Alright, so our mouse events, looking at from the NS point, the window position, the location in the window could be picked up, you know, and captured, the view position. So self, meaning the object that's receiving the event, convert point from window position, from view nil, or whichever, depending upon what view you're specifying. If you're not specifying a view, it's nil. So if event click counter is equal to 2, means they double clicked, then do something. If not, you can do click count to 1, click count to right mouse click, left mouse click. All of the different events can be captured that way. And then you can drag X, drag Y. Well, we're going to see later, probably not till the iOS class, when we we're going to do a puzzle today in the later class. And so we'll take images and we can drag the images and reposition them automatically. So yes, now you'll have a puzzle. After today, you'll have a puzzle game to go along with your tic-tac-toe game on our primitive games. It's not really primitive, actually. They're really good learning games. So event dispatch and key events. What we're looking at here is instead of the window under the cursor, the keyboard event goes to the key window, so NS app key window. And look at that, first responder. And so each window has what's called a first responder for the window, and it's the keyboard for the text, because that's, if you're going to type into a field, I mean, if you're going to press into a text field or something that's going to take input, it does not always text. It could be right arrow and left arrows for sliders and other controls, and up and down arrows and things like that. But long story short, it's the first responder, is the keyboard that's going to show up for that. So when we resign first responder, we're getting rid of the keyboard. We can actually call the first responder, which is interesting. So if you want to have a login screen and you don't want the user to type in anywhere else, you can pop up that little keyboard. So you just basically say first responder, send the first responder. So you're initiating the event yourself programmatically instead of waiting for the user to press on something. Makes them fill in a box because they can't get rid of that keyboard. So they're stuck unless they back out of the program. So in order for the view to become the first responder, it must also return yes for the Boolean, so the Boolean accepts first responder. So we'll see this programmatically, so it'll make more sense eventually. Key events, there's 2 key event methods on the NS responder, key up and key down. So for game programming, you can have it set so, you know, like what is that thing where the balls come down from the top? And then you can move a slider to the left or to the right to catch the balls or whatever happens to monkeys or whatever happens to be flying down. Very simple with a key right, key left instead of key up, key down, which is the right, left, up, and down arrow keys on your keyboard. So, and basically you're just moving a piece of line or a brick or something, some object that you have on the screen. You're going to be moving with, and you're going to need to capture the key event. So when the customer or the user presses the left key, the thing is going to go to the left versus the right key. So you can do that actually with iOS applications as well. So So for the key events, we can actually figure out, well, which key, for those primitive games, where you have the D and the F, and you can press the keys to kind of control the game. So we can have the NS string characters, so it's character array, essentially. Event characters that are coming through, unsigned modifiers for flags that we're going to put on the characters so that we can put them into ASCII sequences to kind of, use them to identify the keys. Modifiers in the key mask, and then look at, is it equal to, is it a string or is it equal to S? If the command S was pressed, then do something. In this particular case, it's looking for, some sort of a command key plus the S key pressed simultaneously. Because if that happens, then one of the bullets is going to come out and be available to be used in the game or something of that nature. So. iPhone has no key or mouse events that are generated from the device. So in the app, if the user just presses something, but you can ask for it. You can accept it. So touch events instead. But unlike the OS X system, you touch the. Unless you have a touch screen. In fact, I'm waiting for the touch screen version to come out. Eventually, they're going to have to come out with something like that. So now you touch screen, nothing happens. So you have the only correspondence is with the keyboard. UI events contain a collection of UI touches, and so that's where we get the multi-touch support that comes into place as well. And what are we looking at here? Here we go. The touch events. This is what we'll be looking at with our jigsaw puzzle example that we're going to see today. So touch begins, touch moves, touch ends, touch cancels. You can actually pick up touch twice, double taps, which is kind of not too hard to do either. So what you're doing is you're just picking up what the user is doing. So when does it begin and when does it move, when does it end? Well, it's when you release the touch, when you press the touch. Touch cancel, that's kind of a hard one to program in, because here's what happens. You're going to have itsy bitsy little items on the screen, and people are going to put their finger on it. Which one did you touch? Well, you got two of them in the same area, because maybe you have a big finger or something like that. You use your thumb to touch it with or something, and you dragged it, but you didn't know exactly which one you're dragging. So there's a little skill in the design to make sure that the touch events are actually captured correctly. So hard to test that on an emulator. Very hard to test that on an emulator, because you only have a mouse, and the mouse is very precise. It is very precise. So not so precise as the fingers. So here's an example. Some touch events. There's the touch begins. So we have an NS set that we're going to look at, which is nothing more than a data structure that is going to keep track of the set of coordinates that are basically part of the touch sequence, so the touch begins with the event and the UI event is triggered on the touch, and then it's captured automatically. So we stick this method inside of our view controller, and our view controller will automatically receive the event, just like it receives a button press when we press on a button. So what we can do is actually, if we don't want the first responder to go away when we're press the enter key, because what we've been doing so far is undone, exit undone or whatever, which means, and then resign the first responder on a text field for each one of our boxes, right? If we don't want that, we could put a touch event in the background of the view controller, and so when the user just touches the screen, then it'll resign the first responder, wherever the first responder happens to be, which is another way of doing it, because the first responder doesn't work in everything. It only really works well in text fields. Text boxes, not so good. You can press return all you want, but it's a multiple line box. So how you're going to get the functionality for it to continue to write different paragraphs in this text box. So most people would program the touch on the back of on the view itself. And so if it's hitting the view and the view is being controlled by the view controller, then you put this method in the view controller and it automatically picks it up. We're going to see that with the jigsaw puzzle actually today. Event all touches returns all of the touches in the multi-touch sequence. Capture them all. So touches are just the touch associated with a particular call. So if you're only expecting one touch, get it with touches any object. Just one touch on the program. If you had a splash screen that showed up and you want to get rid of it, just one touch would work for it actually. So, Alright. So here's another kind of example of using it with touch events. So UI touches any object. So any object method being sent to touches, and touches was defined up here. Touches as being our object or touch essentially. In this particular case, is going to be our UI touches, but it's going to be touches for any object. So touches are the object. So if the tap count, well, is it going to be equal to 2? Handle double taps. So you can do single taps, double taps, one tap. Don't count the taps. So it's actually kind of easy to figure out what, how many times the person is actually tapping. It's kind of like key presses. Each event is triggered for each one of them. And it's buffered actually, so that's where the double tap comes into place. It knows if you've hit it twice or 3 times. So CG point here in this particular example is just going to draw, looks like it's going to take the touch and from the previous location in the view to a new location. So you're going to put something from here to here. So you're touching on A and then touching on B, and you're going to move whatever object, or you're going to do something with those 2 points. And here's a drag X to the A and the B location. So, and I drag Y. So, turning on multi-touch. So self multi-touch enabled equals yes. Put that in the view did load, and you're set to go. So that is the end of the boring PowerPoints. Actually, not PowerPoints, it's PDF. In fact, it wasn't too boring. Let's check out the trash open. So this one here that we're going to do is, this is what the final product looks like. In fact, let me just run it for you so you see. But before I do that, let me show you where you can download it. Oh, we have no server. Let's see. No, I got the server back. It looks like it just came back. Here we go. Looks like we have some sketchy internet access today. So, in object-oriented programming in Objective-C, in the source code examples section. And this is, we're not doing this one yet, plist tutorial. I'm not going to do that one yet. We're going to do ColorChooser tutorial and ColorChooser solution. So download both of them if you don't want to cut and paste from the tutorial. Because again, these are old PDF files, so we'll see what happens. But there's not too much cutting and pasting in this one, so we're pretty good. In fact, you don't have to cut and paste if you want to type it all yourself either. But these are the two that we're going to be looking at. We also have the jigsaw puzzle. I'm going to wait actually for the iOS class on the jigsaw puzzle. And you guys who are in this class who are not in the iOS class, you can do this one if you want as well. I should move it over to the other. I meant to put it over in the other one. But, so that's the tutorial that we're working with right now. And let me scroll up to the top of this one here. Let me show you the final product so we can see what we're building. It's kind of twofold because then we can sort of see the views in the windows, which was kind of our theme for today. So, and capturing events, slider events actually in this particular case. So if I run it, I'm going to have, it's a very simple application actually. No separate class files, just one view controller, one view. It should be loading. Yes, it is loading. So it comes out, and initially, because I set the background to green, setting the background to green, so if I move the slider here, add some red, you can see I have green and blue turned off completely, so it goes to the RGB scale as well. So you can see, add some green to it. Ooh, that's a lot of green. Take some green out, put some blue in there. And I have purple. So this is what the app's doing. So we're going to capture, not only are we going to look at the view here, but we're also going to capture these events of the changes, and as the slider moves, we're updating it here too. So the number here and the hex is here, so the number in the text field, which we can actually type in here, so I can go 100 as an example. So I can use the text fields to change it, to kind of see what the color looks like. But what you might want to do, you can probably, if you wanted to, you could use this app to kind of figure out what shade of blue do I like. There it is, right there. There's the RGB, red, green, and blue. So it's not a bad kind of utility app as well to kind of hold on to if you want. But that's the finished product. So the label gets updated and the text field gets updated, and this gets updated with this. So we have multiple different types of data. And we're going to use sort of a cheat sheet method because of these are integers. So although we can treat them like floats, they're still going to be integers. So we can kind of play around with the data. So, all right, so I'm going to actually leave this guy out. And then starting with the tutorial. We might get to the jigsaw puzzle in this. We'll see. Alright, so in this tutorial we're going to see interesting way to set the background color of a view. Looking at different ways to represent the same data and converting from one representation to another, which is what we're doing here. So set up, create a new Xcode project, call it ColorChooser with these options here. I did it for the iPhone, you can do it for anything you want. So if you're following along, now's a good time to open up Xcode. Actually, let me just do it this way. Start it brand new. Single view application. I'm going to call mine Color2, because I already have a color chooser out there. And then I'm not going to use the storyboard. Don't really need to for this. I only have a single view, so it doesn't really matter. And I'm going to save it on my desktop. Alright. So that was the easy part. So it was actually not too hard. Let's see. Next, I always like to do the GUI first. So you guys might have different preferences, but I always like to start with the GUI, because then at least I know what I'm building. So we're going to open up the view controller, and we're going to drag 6 UI labels, 3 UI sliders, and 3 UI text fields to the view, and then arrange them to look like this. So let me show you what the slider looks like, because that one we haven't seen yet. So if you click on the XIB file, you can obviously change your view around if you want, do whatever you want to it. If you come down here to the bottom and type in slider, it comes up automatically. There's only one kind of slider, and that's that slider. So if you drag it over here and stick it on here on the view, and then you can stretch it out. And you notice that the value of it, we're going to change the value, but the value is in the middle. So if you go over to the right hand side over here, you can see the value 0, maximum, current 0.5. So I could actually change the current, let's say to 0. If I did that, I see my slider moved over to here. So programmatically we can see what it got changed to, the event of actually changing the slider and then changing it in the code to correspond to the color of the RGB scale, depending upon what it is. So we're going to change all those in a few minutes, the maximum, I think, is 255. So if you wanted to, we can do that. I'm going to go back and do it in a few minutes. So it means you can't go up higher than 255, which means you can't pick a color that doesn't exist.
Now, how do you get the slider in the utility window?
Oh, so over here, you want to click on the attribute inspector. And click on the slider, and then click on the attribute inspector. So I'm going to put another one out here. And I'm going to put 3 of them out here, actually. And then I'll go ahead and change them, because I'm going to change them in the tutorial in another step. And then, let's see, I made these kind of big, so I'll move them over here a little bit. If you don't like the auto-arranging that's going to occur, and there's a little button you can turn off that lately I've been turning it off. Let me see if I can find it. User interaction enabled, and we'll leave that on there. See if I can find it first. Here it is here. In the first box, if you click on the view and then click on the first box up here, which is the show the file inspector, down here where it says use auto layout, I'm going to take mine off. Otherwise when I run it, the whole screen gets jumbled up. Because I'm putting this on a 3.5 inch, or I don't know, the simulator is a different size than this window here. So you can optionally leave it on. If you're having problems with your display getting bunched up, the labels showing where they're not showing. If you want things to appear as if you're putting them on here, you can turn it off. If you don't and you leave it on, then it'll automatically adjust for different orientations, for different screens. But I find it a little bit irritating. So I'm going to put some labels out here. A red, green, and a blue. Red. I think green is next. RGB, blue. Blue. Alright, so I got my 3 labels, and I'm going to line my labels up. There we go. And I'm going to put another label out here. This is going to show the results. Instead of it just saying label right now, I'm going to go hex, hash 1, 2, 3, 4, 5, 6. So I know it's big enough. Otherwise, I could alternatively make it bigger like that to know it's going to fit the number. Well, it's going to be 6, 2, 2, 2. So it's going to be 6 characters total. And I'm going to put a button out here. And the button is going to show, actually, do I have a button? Let me see. I'll go back here. I have something else out here. No, oh, I have the 3 text fields and the decimal. Alright, so I'm going to stick that out. There's no button on there. So let's see. A label here. It's going to say decimal on it. And then I'm going to put the 3 for the RGB on here. So I can put here text. These are going to be text boxes. So I got 1. And actually, I want the text boxes all to be the same size, and I'm kind of lazy, so I'm just going to cut and paste them. So I'm going to go like this and go copy, paste. I got 1, 2, another one, edit, paste, 3. Now, if I wanted to, actually, I can do this here and go label. I'm adding some enhancements here, give you guys some time to catch up. Green, blue. So anyway, so I made mine a little bit different this time. These are the values that we're putting in here. Look up RGB on the internet if you have no idea what I'm talking about. So let's see. Let's go back. So change the text in the label controls to match the images above. Red, green, blue. Okay, we're doing pretty good. For the slider, change the values in the attribute inspector. Okay, we are sending it. We are changing it to 255. So minimum value is 0, maximum is 255. Because if we go 255, 255, 255, we're going to hit black, I think, or something. No, we're going to hit, I don't know what we're going to hit. We'll see. We can try it out and find out. I think 0, 0, 0, I think it's black, but let's see. So I'm going to click on my first slider and click on the attribute inspector, which is up here. And I got 0, 0, 255. So now when I click on the next one, it's going to bring up the next one. So instead of using this to go up to 255, I'm just going to click in here and go 255. And then I'm going to change the initial value. It doesn't really matter if we change the initial value. It just means the screen's going to not look the same way you want it to look. So if we put it on 0, then it moves the slider way over to here. So let's say 255. Alright, so hopefully we've all made it this far. Okay, good. I never know. Alright, so also change the keyboard value for the 3 text fields to numbers. Because we don't want anyone to put in anything outside of numbers. If you put in like an A or a B, it's going to throw the game off. It's not game, it's going to throw it off. So we have an option called numbers and punctuation. And then change the return key type to done. So here's our little window here. Under the keyboard, we're going to change it to numbers and punctuation. And then the return key, we're going to change the done. This is on the text boxes. So in the middle here, keyboard. See, we have all these little options here. So it won't take anything but a number. Or and punctuation, numbers and punctuation. And then the return value is going to be done, which is going to trigger our done exit on done, which means if it's going to generate a done, and we don't actually have to click this box here. It says auto enable return key. Doesn't really matter. So in this particular case, because we're going to put a responder event in there. So on this next one, I'm going to put the keyboard type to numbers and punctuation, and number pad, phone pad. Interesting. Twitter. So different options there. And you know, actually you can play around with all the little different options and see what they do. Say blue, take the keyboard, put on numbers and punctuation, keyboard type is done. There you go. Alright, I think we should probably be done with our interface by now. I'm going to leave the background on gray. Let's see. So now we're going to go and we're going to wire the 3 sliders and the 3 text fields and the 1 hex label to create the properties. You know what I'm going to do though before I do that is I just want to run it, make sure I've got a workable project. Because when we start wiring, that's when things start getting messed up. So after I create my beautiful interface, then I run it to see what it looks like. And then I can go, ah, look, it looks so great. And then I can mess it up after that. Actually, there's some people that would actually close the project down and copy and paste it and zip it up, just to make sure that they have a fresh, because do you really want to start all over and do this again? But you see, the sliders work, just nothing happens. In fact, let's see. Oh, that's not good. Okay, so all right, so we're not quite there yet. So I was going to type in the boxes, but I can't see the boxes because it's covered up. But now, if your display was all jumbled up, then click on this far left one over here to get into the file owner, file inspector, and turn off the use auto layout, if that was the case. So amazing how much it happens more often now in the later Xcode versions than it did in the earlier ones. I think it's because there's just so much automation going on now. So now we're going to open up the view controller, and now I can practice wiring components again. So we're going to wire the 3 sliders, the 3 text fields, and 1 of the hex labels. Well, we only have 1 hex label. So what I'm going to call, I'm going to do the sliders first. I'm going to call it red slider, green slider, and blue slider. That way I can cut and paste the methods and not have to worry about it. These are all properties, by the way. So we know what properties are, I hope, at this point. If not, think of them like variables, but they're associated with the GUI components. So red slider, green slider, and blue slider. So if I click on my little editor in the middle here, I got my viewcontroller.h file that comes up. Click that one away, and now I have a nice clean palette to work with. We know we're going to stick them between the interface and the end. And we're just going to click on the slider just like any other event. Press down the control button, come over here, and call this one red slider. And now we see the type is automatically set to UI slider. Won't even let me put it on ID because you can't treat it. A slider is a very special kind of component. You can't really treat it like a generic component. So it's not going to do that. So connect. And now I have my solid box. It shows me that's the slider. This stuff should be, at this point in the course, this stuff should be really old. Should be like, you can do this in your sleep stuff. Slider. After you do it like 1,000 times, then it's all the same stuff. Slider. Alright, so now I have my red slider, my green slider, and my blue slider. So what else do we have next on here? We have the 3 text fields, a red text, a green text, and a blue text. So I'm going to do the text fields next. I don't know why I like doing them in groups. That way I keep them together, I can find them. So now I'm going to go over here, and I'm going to wire the fields themselves, because we're going to change them. We're going to use them as properties. We're also going to, later on, take this did end on exit and wire it to a get rid of keyboard method. But at this point now, we just want to be able to talk to the red, the green, and the blue text, so we're just going to drag them as properties. So this is red text. And just make sure that that's what I called it in here. Red text, green text, and blue text. So this reminds me of a red text. What is that? The Dr. Seuss. There was just a remake of this movie too. Green, like not Green Eggs and Ham. That's red text, blue text. Anyway, let's see, green text. So I'm going slow enough to keep, because somebody said you have to go slower. So okay, I'm going slower. Blue text. Now I got my text fields in there. You got your text fields in there as well. These are no-brainers. We've done this millions of times. You guys should know how to do this already. All right, so now what do we got left is we have the hex label, the label that's going to be called hex label, and I believe that's the last thing actually for our properties. So we have 1, 2, 3, 4, 5, 6, good, 7, good. So I'm going to go back and put my label in here. This is my label here, and I'm going to control drag it here and call it hex label. All right, good. So now we're going to add 2 new method prototypes, because why? We need these IB actions that are going to be associated with what's going to happen when the sliders change and then when the text field changes. Because remember, we can type numbers in the text field and have the color change as well. So now I'm going to take my chances. I'm going to copy it out of here. I'm going to put it in here. And I'm going to put it on the bottom. Oh, and it worked. Very good. So notice when I did that, because I created IB actions, I got blank little boxes here. So instead of dragging them this way from the canvas to the thing, which we can do, we could have very well just accomplished it this way. It's easier sometimes in this particular case, because if we go here and we click on this here, right click, what do we got? We got the reference here, and we have all this drag, touch, changed. We just want the slider itself, and this is going to be the slider changed event. So in the notes, we're going to actually drag it the opposite way, connect it from the code and put it onto the slider. So drag from the slider change action to all 3 of the slider controls. This gets wired to the value changed event. If you drag it over to the control and put it on the control, it'll actually wire itself, or it should wire itself to value changed. If not, we have a problem. So let's go take a look. So I'm going to take this guy here and drag it this way. So I'm going backwards. They work both directions. Let go. And now if I right mouse click, I see down here in the bottom value changed. If you don't like that, you can do the opposite. You can come back over here. I'm going to, for number 2, for example, I'm going to right mouse click. This never seems to work for me, but I can drag it here from value changed, hold down the control button. Now it's going to work. And I can go this way. So now I have value changed. It's interesting because when I say it never seems to work, it's because it never goes to this button here where I try to do it. So I'm going to do it again here to demonstrate what I'm talking about. If I click from value changed over, I'm pressing down the control button, I actually have to like highlight the code. This doesn't work. That's not going to work, which is, I think is kind of weird, but
counterintuitive.
Yeah, you actually have to go this way to connect it. So now it's connected, value changed. And you know, we know how to get rid of it, right? We just click on this little thing right here to get rid of it. So then it removes it. So now we have it as a property, reference outlet, blue slider, and we also have the sent events. The sent events is going to be the value change. So whenever the value changes, it's going to send the event, that I was talking about earlier with the event stuff, it's going to send the event over to the view controller. View controller is going to pick it up, and this method is going to run, the slider changed method. Now the text field is going to change too. So let me take a look here and make sure I'm doing this correctly. Also drag the text field changed action to all 3 of the text field controls and select to wire it to, let's see, and select to wire it to the did end on exit. So we're going to take and we're going to do the text field change to the did end on exit, and then connectors should be, everything should be connected at this point. So we could right mouse click here a little bit easier actually. Take the did end on exit here on the top, press down the control button and wire it this way. We could do the editing changed, but we're going to end anyway. And we're going to use the same technique in the iOS class for part 3 or 4 or whatever of the what were we doing? I don't know. Whatever that tutorial is going to use that as well today. Oh yeah, the list view with the plist files. Yeah, they're still working on that one. So go ahead and wire these up to the text field changed. Alright, so I have everything wired. I got that one there, got that one there. I got them all wired correctly, hopefully. They look pretty good. Went slow enough, I think I did everything correctly. Alright, so now we're going to make some few changes here. We're going to make sure that we've had all the connections are correctly done. Yes, we have. And now we're going to change over to the viewcontroller.m file and make the following changes. We're going to add a private method. So let me show you something interesting actually. Click on the viewcontroller.m. Remember when I always say, don't get rid of this time. Remember I always go, oh, let's just get rid of this, I don't like this in here. Well, there's a reason for it actually. I don't like to use it, but there's a reason for it. You very well, everything you put in here you could put in the other one. But if you're just going to use it inside of this implementation, it's not really part of the class, it's just a helper method, or helper control. You're making it private. It's a private method when you stick it in here. So we have private methods in here. We have public methods in the .h file. I can make it all public when you think about it. It doesn't. If you're going to use inheritance, that makes a little sense to make it private because then you can't touch it outside of that. But if you're not going to do any inheritance in the project, anyway. So this time we're gonna make some private methods. So we're going to add here to the viewcontroller.m at the top, we're going to create a private method, and it's going to be set label colors to contrast with background. So I don't know if you noticed, but those labels were changing color when we were pressing them. So we're going to put that guy in here. So I'm sticking him right here. And now I have a prototype method. In my interface section, between my interface and my end, that's part of my .m implementation file. So this is private because it's not part of our public interface, which was our interface viewcontroller.h. We're putting it inside of viewcontroller.m. Some people like to drag and drop and stick stuff in here. It will work, actually. You can put everything you want in the .m, but you're kind of doing it incorrectly at that point because you're making it all private. What if you added another class to it, like in the friends for the, now I'm finally remembering the list view with the friends. What if we put another friend in there and the friend wants to talk to another friend and it's not in a different view controller? It's private. You can't share it. So you might end up with a problem with that further down the road. So put your function prototype in there and let's go down to the next one. Oh yes, we have to synthesize. So add the synthesize statements for the properties as follows. I'm just going to cut here. I'm having some good luck cutting today, because this isn't really complicated code. This is really easy stuff. So right underneath the implementation, all those properties that we created, about 7 of them I believe. This is another way of putting them in. Yeah, they could all put in one, you could have put them all on one line. So this is red, green, and blue text with red slider, green slider, and blue slider, along with the hex label. However you want to do it, totally up to you. In fact, you can cut and paste from that PDF file and do it the same way. So now we're going to actually implement this method that we put the function prototype in there for, method prototype. So let me cut and paste it and we'll see what happens here. And it's working with the graphic libraries that we just looked at the PowerPoints for, or the PDFs for. It doesn't really matter. In fact, that's the other interesting thing in here. It does another note to make. I always put the view did load on the bottom and I put the new stuff on the top. It doesn't really matter where you put stuff. Some people do the opposite. They put the new stuff on the bottom. Oh, good. We made it. Having some luck cutting and pasting today. Okay. All right, so this is the method up here, set label colors to contrast with background. That's going to be called. We're going to obviously call it from the slider, probably, and the text buttons. Okay. So what do we got here? We got a CG float, which is a data type. It's a computer graphic float from the computer regular, not OpenGL, but the regular graphics package libraries that we get, that where we saw rectangle and lines, and it's a float. So we have the red value, the green value, the blue value, the alpha value. And then we're going to set each one of the colors to contrast with the background. Self, that's our window, dot view, dot background, get the red value, get the green value, get the blue value, get the alpha value. And then for the ID in the subviews, so now we're going to take the subview. So instead of going to each one of the different labels, what we're doing is we're setting the colors of the labels, the text that are in the labels. So we're just going to get the ID from the subview, and we're going to look for labels, UI label class, which is where this is coming in. We're looking for a UI label. For all the UI labels, I don't care how many there are, we're going to set the color, which means the hex label gets set too, along with the red, the blue, all the labels get set. So if you put some other labels out there, that color is going to be changed too. Okay, so for the ID, each one of the IDs in the subview, in self view subviews, this is the key here in the subview. If the subview is a member of the class, I think we saw this, is member of class already. If a member of class in the introspect example, UI label class, then UI label set color. What am I going to set it to? The UI color, color with red 1, red value green, minus red value blue, minus, so 1 minus all of the different values that we're going to get in there, so we can set the values of the red, green, and blue. So it's supposed to be changing color with the values that we're setting. In fact, it does change color slightly. You can almost read the text, but it's almost the same color as the back, but it's slightly off. So I believe it's lighter in color than the background because we're taking the negative of it. So that's our color setting. So now we have to put this label. Now we have to put this method to use inside of another method call, and we have 2 method calls that we're going to be working with. One of them is obviously the slider changed, and then the other one down here is going to be the text field changed. So the code's going to be very similar, except for the slider is going to take the value that's in the slider and use it, value divide, and for those people who are into color, maybe this red, green, and blue, the values never make any sense to me, but there's a red value, a green value, and a blue value. All of them get mixed together to come up with the RGB scale, or the hexadecimal equivalence to that that's used in programming to specify the color in the palette that you're using. So set the background color from the sliders, because this is the slider change. Just going to change our background color. So self view background color equals UI color. So we're going to make a UI color from color with red, and then self slider value red slider dot value, whatever value is set there, divided by 255. Green, blue, same concept. So the dot value is a way of not using a setter and a getter. It just actually gets the property setting. So whatever it happens to be, when the sliders change, it's going to take all 3 of them, the values themselves, calculate out, and we're going to create a color out of it. We're going to create a UI color from it. So instead of saying UI color is red color, we're going to pick it from the slider locations. Set the text fields. So then we're going to take those values that we just translated for the color and put them in the text field. So this is the self.redSlider.value. And then here's where I say we're going to do some data translation. We're casting it to an integer. When it's really, it doesn't necessarily need it. It's actually a float value, but we're going to cast it to an integer. So we put this int in here to do the cast, essentially. Because when we want to put a whole number in there, we don't want parts of a number, which is where we're going to get out of that slider. And we're going to create a string with the format, and we're going to put in here this self.red slider.value. And then self.green and self.blue, same concept all over again. Then we're going to update the label. So self.hexLabel.text is going to be equal to, scroll dropped on the bottom, the red, the green, and the blue values substituted in here. So it's going to be string with format. It's going to be of the 3 values. So we're just taking the 3 values, making a UI color from the 3 values, updating the text fields with the 3 values, updating the hex with all 3 of them together to create our final products. And we're doing O2 precision here to get rid of the, in fact, we're not even converting it. We could convert it to an integer and put the integer values in instead of doing the formatting this way. So instead of taking the precision out of it and just going 2 places without any decimal on it. So these numbers might be slightly off, actually, depending upon how we could have rounded it. If it was like 12.9 and we put 12 in there, it could be slightly off. Maybe we want to put 13 in there. So, but that's all the code is for the slider. So let's look at some more code here for the text field before I copy and paste it in there. This appears to be a little bit easier to read. So I probably should have put a space in between, but let's see, the text field change. Set the sliders from the integer values of the text fields. We're going in the opposite direction. So we're going to put, and I don't know why this one's green and this one isn't green in my formatting, but maybe I had my cursor here at the time when I cut and pasted this. But self red slider dot value, green slider, blue slider dot value. It's going to be equal to, well, in value for blue text.text, green text.text, and red text.text from the self. So set the sliders from the integer values, which is what this, int value, which is a method call that's automatically going to get the int value from the text. Excuse me. It's automatically going to set it. Yes, it's automatically going to get it from this value here. So we're using, this is what I said before, it's kind of a tricky conversion without having to convert. So we're casting it to integer, and then we're taking those values and we're getting int value. It's like you can use the same there, string value, float value, int value. They're all method calls that will automatically convert the text to, so it'll automatically convert the text to that particular value and then have it equal to the slider value. So set the background color from the sliders. So set the sliders from the integer values of the text boxes, set the background color from the sliders. Same thing as we did before. Those should look familiar. The same code's up here on the top. And this is should look familiar as well. So this is setting the hex value in the labels using the format identifier here for the hex values. The same code as before. Same code as before. We're going to set the integers. We're going to cast the integers. And then I forgot to mention it before, but we're also updating the labels. So here we're updating the set label colors to contrast with background. Running this method. Should it be running at the end of this one? It is running at the end of both of these 2 methods. Both of the 2 methods are calling the private method that we created in the previous step here, which we haven't implemented yet, I don't think. Or have we? I don't think we've implemented it yet. So yes, we have it here. It's the first one I copied in there. So it is setting the background to the values of the sliders. Excuse me, the backgrounds of the labels. Yeah, we went through that first. So okay, I'm going to cut and paste now these 2 methods and stick them in. And we're gonna, looks like we're going to change, we're reading ahead here, the view did load is going to change too. Because when the view loads, it has to change itself to the background color currently set. Or maybe it doesn't, maybe it's going to be set differently, I can't remember. So I'm having great luck with my cutting and pasting. I think it was just that old tutorial. These are newer. I think it was some of the older PDF formats didn't cut and paste well. Alright, so I'm just going to leave it alone. I'm not going to fix anything here, make it look better at all. I'm just going to leave it alone. I'm going to go back to here because we've already gone through that. So finally change the view did load method. So if we change the view did load method, what are we going to do to it? Well, we can do it, to set the red text, the red slider, the blue text, the blue slider, the green text, the green slider to nil. So it's not pointing anything. So then we see the background color. So we can do this type of change C assignment as long as the types are the same. So we have this is equal to this, which is equal to this, which is equal to this, which is equal to nil. So it's kind of an interesting way of assigning it all in one shot. So I'm going to just kind of copy these here because we're going to set them to nil. Then we'll actually see the code works. So I'm just going to stick it under here in the viewDidLoad method. Otherwise, we might get garbage. For example, we moved the red, and we didn't move the blue, or we didn't move the green, and then it starts making a color out of whatever memory happens to be associated with it, because we didn't initialize the value of it yet. It's on 0. So what do we do here? This is everything I just started talking about. You can read this on your own. I'm not going to read it to you. But this goes through what I just mentioned. I'll just to make sure I didn't miss anything in the analysis. Synthesized everything. After synthesizing, we changed the slider. The slider change method, we converted the 0 to 255 range from the slider to the 0 and 1 range expected for the RGBA components, GB components, or A's for the alpha character, alpha measurement of the UI controller or UI structure. Formatting the hex itself using the format for the string and the slider's int values. We typecasted it to int actually for that. And then the 2 indicates the field's width, 2 characters, no decimal points. So. And then the changed field works a similar way. ViewDidLoad, we simply made sure that the label contrast in the background is a black background. So when we open it up, it should be a black background. Actually, I don't think it is. I think it's going to be set to your initial color. Initially set on the view. So whatever. Oh, we didn't set the background on the view. Whatever background's on your view is going to show up naturally. So in the ViewDidLoad, we also set the subviews in the main view to nil to ensure that the reference counter releases these objects as well. So we don't have anything stored there. So now you can run it, and we should get our results. So if we run our project now, I'm going to leave my background on gray. So run it. I should have a working program at this point. So we just played around with color. And the trickiest part with this is making sure you're using the right values and not using floats and you're putting in integer values without any of the natural data conversion, which was kind of a makeshift way of doing it. So now I got the gray background. So now I have black. 0, 0, 0, I guess it's black. So what is the maximum? Oh, I'm not changing. I'm bugged. I have a bug in my program.
Yeah, it should be white.
I'm sorry?
It should be white when it's on the other.
Yeah. Whoops. My program's buggy. Broken. Well, let me see what's different. It could possibly be the let me troubleshoot this for a second. The view changed. No. Let me set the background. Let me set the color. Maybe because it's let me set the color. I can't imagine that causing a problem, but should work actually. Unless I lost one of my connections, is what I'm thinking. Yeah.
Any way to step through one line at a time?
There is if you put if you mark little marks, and then it'll stop at each one of the marker. You can see. This should be working now. Alright, so when I touched it, it set it to nil. Okay, let me see 1 second here, real quick here. Go back and take a look at the code for a second. And let me compare it here, actually. cheat sheet faster way of doing it. Because this one, I know it works. I just did this the other day to test it. So let's take a look here. Just want to compare it. So these guys were set. Let me take a look at the dot. I'm not going to spend too much time troubleshooting it, but you changed. No, red slider. Okay, good, good. Interesting. Could be a property that I didn't set. Can't imagine. Should be the same code. Oh, the view did load. The view did load. I didn't. View did unload. Okay. So let me see if I didn't follow it correctly or if I was not reading it. So the view did unload that we needed to change. We did it on the view did load. View did unload. Hello. So we nilled out everything, which is why when I touched, actually that's pretty good. When I touched the controller, everything went black because everything was set to nil. Because on the view did load, I set it to nil. So let's put this code and take it out of the view did load and put it in the view did unload section, and I believe that will fix our problem. So this is the, yeah, take this one here, take this out of here. Because on the unload, we don't have a view did unload. No problem. Just take and copy the whole thing here. In fact, on the view did unload, are we really going to notice the difference? Well, if we were switching between views, this will zero out the objects. Or not zero, that will clear out the memory for the objects, which could cause a memory leak if we left that out. So let's run it now. Yeah?
One more method you need to paste in view did load. You need to call that set label.
On the view did load? Did I leave that out of my instructions perhaps? Oops.
Set label colors to contrast with background.
Yeah.
Oh, okay. So, that'll set the initial view to the that'll set. Let me see. Actually, I'm kind of curious. Yeah. Okay. I left that out, so I need to fix that. I need to fix the tutorial to put that in then. So we're calling this initially. So this is the part that I left out. So I have to remember that actually, because when I run this again, people will have the same problem. Oops. So on the view, did you get yours to work? Okay, good. So this is the part that I left out, actually, was in the view did load, we have to run that initial private method, and then in the view did unload is when we set everything to nil, because we're trying to clear it out. So let's run it now. So, how am I going to remember that? I'll make a little note to myself. I have to fix that tutorial. So. And then I'll put that in red, so when I look at that, because we always change the view did load. So, oh no, it set the numbers, it didn't set my background. So, oh no, it is setting my background correctly. Okay, so we are now working again. So apparently, well, that's the set the label colors contrast. So the setting the label color contrast shouldn't matter with the background, which means that should work without that. Let's just see real quick here, actually. If I leave out that instruction, if I move the red, black, and green over far enough, I should get some color on that background without any initial coloring set. But it would be nice to have the labels set. Don't necessarily need them, though. Oh, there we go. It's just when it, on the view did load, it's giving me black labels instead. So I could optionally just leave that out, actually. And so the tutorial is correct. I don't have to change it. I don't have to remember to change it. It's already. It will work if you put it in the if you nil them out in the unload. Okay, good. And the values are showing up properly. And the numbers are changing. Okay, good. We're working. Hopefully you guys have yours working. So. Questions on using the sliders and changing the values programmatically? Nope. Okay. And then I wonder why I put that in there. Huh. Nah, it's optional.
When you can't read the labels when it's set a certain color setting. It's right in the middle. You can read the labels.
Oh, let's see. If it's set in the middle, you can't read the labels. Yeah, you're probably right. Actually, if it's going to match the... I put this in so it would change the labels when it originally loaded to see if that, because I thought that's what you were saying. But I don't think that's what you're saying. I'm saying if you put it in the middle, you're saying you can't. Let's see. So now the labels are changed. So you're saying if we put it in the middle... Yeah, it's hard to read it, yeah. You can still kind of see them. They're a little bit lighter in the background. So. At certain points, they get hard to read. So it's kind of like web design, I guess. You know, if you put dark text on light background or whatever, or dark text on dark background. So, you know, optional, you could take the text part out of that. Don't change the label colors. So this, when I had this out originally, it wasn't changing. It was coming up black originally, and then it changes. In fact, you could probably remove that completely if you wanted to. So, I mean, and have a better looking program probably at one point. It's just showing you how to get at the IDs of the labels and change them. All right. Well, that's comforting to know that the tutorial is not wrong. It's just the reader of it that's wrong. So, let's see. Close this guy. All right, so the next one we're going to do, I'm going to do the jigsaw puzzle, I believe. I'll do it in the next one because I think the iOS people might be more interested in it. We have actually one more time. We have some more time left here. We can do the plist, which is really the one that goes right before the tutorial that we did last time in the iOS class. So let's look at plist here, actually. Oops. And it's a simple address book using the plist, which doesn't require you to actually cut and paste and move anything over, because this is more advanced actually than the one we did last time on the iOS class. Or we can parse HTML code. 4:30. We got about an hour. Let's parse HTML code. Let's do that one instead. So this one here is actually it's more oriented towards Objective-C anyway. So it's because it's more programming related. So Spring 2013 object-oriented programming and Objective-C source code examples. This one is parse HTML tutorial and parse HTML solution. So it's text parsing. It's kind of like what we did with the number conversion from Fahrenheit to Celsius earlier on in the course. So it's basically showing us how to read something off of and parse something in. This tutorial will work with parsing XML and parsing HTML because it's all done the same way, looking for opening and closing tags. So what are we going to look at here? There's a test page out here, and the test page that we're going to look at is already created for you. In fact, if I open it up in a web browser, if I have internet access, which I do, brings it up over here. You view the source of the page. It looks pretty simple. Anybody know how to view the source in here? Yeah, there's a control something or other. You hit control view. No, view source isn't going to be in here, is it? No.
Under tools.
Under tools. Where do you see that? I know they have it in.
Right click on the browser.
Yeah. View page. Here we go. Thank you. See, I knew someone in here would know about that. Not very much of a web developer myself, but I can navigate it to a website. So we have an opening and closing HTML tag, a head, opening and closing, body, opening and closing. Typical HTML page. So if, let's say there's a page out there, usually with XML code you're going to want to parse it. It's a little easier to do it to kind of understand what's going on with a HTML page, but the concept is the same. So here's the page, and we're actually going to go to this website to parse it. So that's why I'm showing it to you. And this is a picture of it in here, and the page is still out there, so I just verified that, so we're good. I haven't deleted the page since the last time I did this. So start Xcode and select create a new Xcode project. Choose a single view application, and this one's going to be called ParseHTML, and here's the screen. It's going to show us what we're going to need to do. So we're going to Xcode, create a new project. I'm going to call mine Parse because I already have a ParseHTML. Single view application. Parse, there we go. And it's going to be an iPhone application. It's going to use automatic reference counting. So we're good. And press create. So far so good. Open the project up. So we're going to put an object in here. So this is going to be an HTML element. The reason why this is in here is because we're going to add a couple of objects. Allows us to kind of make instances of objects and use objects inside of other objects. A little bit more Objective-C oriented in terms of the concepts. So we're first going to create an object to hold the HTML data, and then we're going to name this particular is going to be called an HTML element, and it will just be a simple Objective-C object that is inheriting from NS object. Yes, we can use NS object inside of an iPhone application. Works just fine. Doesn't have to be a view controller, it can be an object. So select a new file, and then under the ColorChooser, make sure it is under the ColorChooser, Objective-C, inherit from NS object, and call this one HTML element. So let's do that. File new. So I can do it this way, which is how I kind of like to do it. Or you can click on the project here and go new file. You can do it that way as well. Either way brings you to the same screen. Make sure you have a ColorChooser on the top here categorized. There we go. Select the Objective-C class. Hit next. I'm already on NS object. If not, make sure you're inheriting from NS object. And this is going to be called HTML element. Let's see if I called it the same thing. HTML element, perfect. And then go ahead and click on next to add it in, and then create. So mine ended up over here because that's where I clicked. It can be here, you can drag it like we saw before, we can drag it in if we want to, put it inside the project. I'm just going to leave it right there, it's no big deal. So our new object will hold two NS strings, one for the name and the HTML tag, and one of the value of the tag. So one's going to be the value of the tag, one's going to be for the name of the tag. So open up the HTML.h and add, TOW, should be say two properties as follows. Tag and value, so we got two strings. So we're just going to do this, copy, put it into the, open the HTML.h file, which happens to be open here. This is the M, so I want to open the H file. There we go. And I'm sticking in here two properties. And because they're properties, I'm not putting them inside of these opening and closing brackets. Because they're not data members, they're actual properties or objects that we're adding to it. So that's not necessarily, that's not needed. So our two properties for tag and value. And because we're going to read some stuff in, we're going to parse it. We don't actually have to put a web view up here either. We're going to do it all programmatically. So the only thing that we're going to need in the implementation is to synthesize our variables. So open up the HTML element and add the following line of code, synthesize the tag and the value. So our HTML element is pretty simple. We have two properties. That's it. Because it's an object just holding two values, a tag and a value. We're going to take and create an element for each one of the lines or each one of the pieces that we're going to get. And we'll see the parsing. And the parsing is going to be in a separate object in itself. So this will represent, this object will represent each one of the components, so the elements. Next we need to create a parser class. So that was our element class. So this is a kind of a very typical way of designing the objects. So you have one object that represents this, one object that represents that. And you separate all the functionality so it's easier for, not only in the future, but it's easier for you to understand when you go back and you look at it. So So we're going to do the same thing as we did before. This time we're going to create HTML parser, and the same way that we did it before. So I'm going to make sure I have the name here correct. HTML parser. So I'm going to go back into Xcode. Because I stuck these guys here, I'll put these guys up here too. So I'll go file new this time. New file. Objective-C class. HTML parser. And this one's going to be a subclass of NS object. So go ahead and press next. Make sure you are in the ColorChooser. If you're not in the ColorChooser category, you're going to end up with a problem. So now I have HTML parser up here. So the parser object is going to need to import the HTML elements. Because remember, we're going to use the element inside of the parser, so we need to import it in. So we're going to need to add a line to import it. So go ahead and write the line at the top of the .h file for HTML element.h. So HTML element.h right here on the top where it says foundation. Underneath it, paste or type in there import HTML element.h. So remember those protocols we talked about a long time ago? We're going to use a protocol in this exercise as well. So let me make sure I haven't skipped anything right now. So I'm going to read this thing here this time. HTML element class holds 4 instance variables and declares 1 action. So we're going to have 4 instance variables. We're going to declare 1 action. It needs to implement the NS-XML parser delegate protocol. So we need to change the header line of the implementation in the interface to include the protocol. So add the NS-XML parser delegate to the interface line to use the protocol in the class implementation. This is it here. This is what we're adding. Because we're using this protocol, if you remember back when we had the protocol lecture. And we made protocols for, what did we do? For pencils or something. I can't remember what it was for. So we stick it in both. So right here, actually, I'm sorry, we stick it right here in the implementation. Excuse me, in the interface. I can't talk today. So now we have just said that we're going to use the MS-XML parser delegate, which is the protocol that's going to give us the necessary classes that we're going to have to implement to perform the parsing. So we're going to reuse what's given to us. Add the following 4 properties and 1 method prototype. The 1 method prototype is going to be for the parser. Load HTML by URL. This is coming from the prototype, excuse me, from the protocol. This is a method prototype that we're going to implement. The other strings are going to be used inside of this method. It's going to be used to process the string that we're reading in. So I'm just going to cut and paste this here, copy I should say. This is going inside of the interface that's going to be part of HTML parser. So we're still in the interface. I'm going to paste it in here. Make it look better. There we go. So now I have a NS mutable string, a string that can change, a mutable array, an array that can change, because we don't know exactly what we're going to get, how big the string's going to be, how many items we're going to be storing from a page. And then this is the built-in data type we get from the protocol. This is defined. NS-XML parser is an object that's created in the protocol. And then HTML element, well, that one should look familiar. That's our HTML element. That's going to be our current HTML element. So we're making an instance of our object HTML element that we created that has a tag and a value associated with it. So you can make your own dictionaries this way, your own HTML elements, your own kind of, and then add it to the project. If you already have it created, just put it into the project. So actually having to recreate it, and then make instances of those objects, just like you make instances of everything else. Now we're ready to do the implementation. The first thing I like to do is do the synthesize. Just make sure I don't forget to do that. So we're going to synthesize those 1, 2, 3, 4, 5 elements up here. 1, 2, 3, 4. And there's only 4 of them. 1, 2, 3, 4. 1, 2, 3, 4. 4 elements. So go ahead and switch over to the .m file of HTML parser. And in between the implementation and the end, paste in the synthesize. Now we have our little variable synthesized. Also need to add the implementation for that one method. Remember, I got the 4 data members in that one method. And the method is going to be loading, and this is the heart of the entire application actually, which is going to be loading the HTML by URL. So take a look at it here. It's pretty small. So we saw with the web view, we can create a URL object, so NSURL. So this is a pure Objective-C actually. So it has nothing, because it doesn't say UI, it's Objective-C from regular thing that we would use in regular old, OS X development. URL is going to be equal to an NSURL of URL with string, URL string. So we have to give it the URL. Probably going to give it to it in the view did load, perhaps. Maybe in the app delegate, we'll see. Probably the view did load is what I'm thinking. NS data, we're going to allocate an NS data object, and that one's going to be in it with the contents of the URL. So we have this generico NSURL object and this generico NS data object. It's going to be predefined objects in Objective-C that's going to hold these pieces of information for us. And then an element array is an NS mutable array. So back in the way beginning when I went over data types in the first part of the course, I went over the concept of different types of arrays and dynamic and static kind of components. We have the ability to have this thing called a mutable array, which is one that can change. So just as the word means. So it can change inside throughout the execution of the program. And it's mutable array alloc, we should be familiar with that. Init, initialize it. And then we have our parser, which is going to be our parser. Our parser is going to be an instance of the NSXML parser. That's this object that we loaded in from the protocol. So that's our parser object that we're getting from the protocol implementation. And so we're going to take and we're going to allocate an NSXML parser. And we're going to initialize it. We're going to initialize it with the data that's coming in. So we're going to send the data from the URL, which means the URL is going to basically get loaded up. And when we get the URL, it's going to go out, find through HTTP protocol automatically. Find what's there, take all that, add it to a data, NS data object, take the data object, send it to the parser object. Parser object is implemented with the predefined code that we have in the XML parser object. And then parser.delegate is equal to self, set the delegate to itself. Parser parse, which is going to be the method that says, okay, parser, parse it, which means separate it out. And then the current HTML element is going to be equal to a new HTML element alloc. So we're going to create a new HTML element for each one of the items that comes out of the parsing. And then return self. So I'm just going to cut and paste and put this in. So this is how you can basically take advantage of protocols. So it's a really good example of a protocol. And I'm in the HTML parser. And so I'm going to paste this in, and now my yellow thing went away. Because I had that one method defined in the .h file, but I didn't have the implementation for it in the .m file. So it was complaining about it for a few minutes there. So no more complaints, I haven't implemented. So now we need to implement three methods to follow the parser delegate protocol. If we don't implement these methods, we're going to have a problem. Well, we need the functionality, but we're still going to have a problem because the protocol is going to complain when we go to run it. So what are the 3 protocols? Well, these are the 3 methods, in the protocol that we're using in here. We're using parser. So we have parser, which is going to take and did start the element from the string, and then from the URL it's going to take the string that comes through, and then it's going to allocate a new current HTML element for each one of the strings that came through. The whole thing is going to end up in an element here, current element. And then we have parser did end element, so did start element, did end element, and it's all of string format. So if it did end, then we're going to create a string here for the title. And then we're going to take each one of the, we're going to check each one of the elements to see what it is, and then categorize it. So after we've read it all in on the end, so did end element, if the element name is equal to title, which is what is in our HTML code. So we have HTML is the beginning, and we're not capturing that. We could definitely put it in here if we wanted to. And just say, hey, it's the start. So the title is actually up in the head section. We didn't put the head in here either. Current HTML tag is equal to HTML element. And then the value is going to be equal to the current node context. So that's the value. And then the element array add object to the current HTML element, and then set them to nil to start with the next item that's going to come through. And then if it's equal to h1, if it's equal to p, div. So this is where the brains of the operation is coming into. What we're going to do is just load it up into a table view. That's probably what we're going to do here. So we'll see how to dynamically create a table view object as well. But we have all these pieces that are being parsed through, and so we're taking the HTML element, finding out what it is, and then giving it a certain label for the tag, if it's a tag. And if it's not a tag, then it ends up being, well, we have tag value association that goes along with it from the parsing. And then we had the found characters, nothing more than finding the character and getting rid of the white spaces. So we can remove all of the white spaces out of there. So I'm going to kind of paste these, hopefully successfully, and stick them. So this goes into the implementation. So we have the parser did start element, parser did end element, and then the parser found characters instead of white spaces, because it's just ignoring the white spaces. And I'm going to paste this into the right underneath here in the body of the okay. I am in the M, good. In the implement, for a minute there I thought I was in the .h file, because I have it, over here I have it selected, but I don't have that over here. So I'm like, oh, I am in the right file. Paste. Very good. I don't see any major errors. Looks like my pasting job worked this time. Just leave that one alone. Now the rest of the work is done in the view controller. So we're going to change the view controller. Actually, we're going to change the type of controller as well. And you'll see how this can be done programmatically, so without actually having to create a new controller. So the rest of the work's done in the view controller. The head will import. So the header file imports the HTML parser object and declares it as an instance variable. So we're going to make an instance of HTML parser. HTML parser is making instances of the HTML elements when it performs its parsing. So open up viewcontroller.h and add the line to import the HTML parser.h. So I'm going to copy this one here, paste it inside of viewcontroller.h. Which I'm down here now. Viewcontroller.h, and I'm pasting it in. So now this one's going to know about HTML parser. HTML parser knows about HTML element. So these two objects are going to be used indirectly here, which is all I have to do essentially to make it known. Make the view controller a subclass of UI table view controller. So we're going to switch the regular view controller into a special kind, a UI table view controller, instead of a UI view controller by making this change. So I'm going to copy this out here. I probably could just type it, it'd probably be easier. But still in the interface, where it says UI view controller, I believe it's going to be table. Oops, table view controller. I don't even have to paste it, it's too easy to paste it in. But it's UI table view controller, which means we're going to have to change the view to inherit from UI table view controller as well. If we forget to do that, we're going to get a nasty blow up that's going to happen. Actually, I can show you the blow up. Well, let's see if I want to do it. Yeah, I can show you the blow up and you can see the error message and then you can see why it's happening. But make a new property. So remember, we have to do something. We just changed it from view controller to UI table view controller, and the view doesn't know this yet. So remember, that's going to cause a problem. All right, so make a new property for an instance of the HTML parser as follows. So make a property in here, because we put it in there, we might as well make a property of it, right? So let's go back here. In between the interface and the end, I'm going to make a new property. And we have it's an HTML parser from my include. If you get an error message, you probably forgot to include it. So we're all done, actually, with the .h of the view controller. So now we're going to start in with the implementation and use the HTML parser when the application loads up. So I'm going to change it to viewcontroller.m. And then in the viewcontroller.m file, add the line to synthesize. Okay, that's a no-brainer. Put this in here. And then we're going to change the viewDidLoad method as well. So I'll say synthesize the property. See, now I can actually take this out, but I'll just leave it in. Pull that out. I don't think we're using any private methods in this one. So I synthesized it, and so let's go back to instructions here. We're, table view, okay, yeah, okay, so good here. So we're going to essentially add a line, 2 lines actually, to the viewDidLoad. Make sure I have viewDidLoad here. And one of them is going to be using this HTML parser that we created up here, HTML parser. And it's going to allocate a new HTML parser, and then it's going to take the HTML parser, load HTML by URL, and this is the the test page that we're going to load. And self.title, make our title equal to HTML elements. So I'm going to copy this. Put it in here. In the viewDidLoad, I'm going to take out this little comment here, just put it down here. We're good. I'll just leave the funny formatting. I'm afraid to touch the formatting these days. So because we're now inheriting from UI table view controller instead of view controller, we're going to add a new method. And the table view, and for the table view, and set the number of rows in the section method to use the element array by adding the following code. So what we're going to do is add this new method here that sets number of rows in section, and the number. This is overloading number of rows in section from table view. Because remember, when we inherit that 2 dots, let me just remind you of something actually here. This is inheritance. So view controller is inheriting from UI table view controller. Inside UI table view controller, our inherited methods include a method that's called table view that takes on number. It's a table view type that is used to take on number of rows in the section. We also have about 10 other ones, but we don't have to change them. So we can group things together. We can do all sorts of different things to it by overloading those methods. This one we're going to overload it. We're going to set the number of rows to return HTML element array count. So we're going to put a count, which is a built-in method on the MS mutable array to count how many items are in there. And we're going to do on HTML parser, return the element array, count it, and return that number for the number of rows in section. So we know how many rows to put in our table. We could arbitrarily set it to something, but why? Because then we would have more we'd have empty rows at the end of the table. So cut and paste this one and stick it in the implementation of the viewcontroller.m file. So let's see. I have to switch back to viewcontroller.m. And I'm actually going to stick it right here on the top. So now we have customized the number of rows in the table view. And there we go. Now there's one more method we actually have to put in here as well. Everything else gets done in the cell for row at index path method, which is another table view UI table view controller method that we're inheriting from. So we're going to set the current HTML element from the element array and then use it to set the labels in the cells. So this is how we're going to set the cell labels. So in the of data type UI table view cell, which is inside a UI table view controller, cell for row at index path is the method that we're going to run. That's basically going to say that cell identifier is going to be called cell, and then cell is going to be basically allocated and then set to nil, and then as we go through we're going to configure each one of the cells for each one of the HTML elements that we get out of the NS mutable array that we're looking at. So HTML element is going to be the current element, and that's going to be the element from the array, element array, and then object at this index of this row, and then it's going to basically kind of configure it so that the titles are going to show up in each one of the cells as the label, or the title for the cell. And then the cell detail text, label text, and we're going to see there's 3 different sections actually, but we're going to use we're using the title and then the detail, title and the detail for each one. So it's going to say title and whatever the title was, and div whatever. In fact, I probably should have showed you the finished product actually, but at this point I can show you the error, but I may not necessarily want to do that. So cut and paste and put this one in here too. This is basically setting our cell labels or titles and our content or detail content for each one of the table views elements that we're going to show. So I'll go ahead and stick it underneath. There we go. So what ends up happening with each one of these different views, there's different properties that are set, and there's the cell concept, which is what each one of the entries are in the view. So no one goes through and memorizes what each one of the components is. So instead what you do is you keep this little cheat sheet of either Xcode files, projects, examples, references, so that when you go back and say, I want to use a table view. What was that? Well, we have title, we have detail. Okay, we have this, we have that, we have... And then you run through the format, and then it refreshes your memory on it. So it's kind of like, I don't know, nobody memorizes syntax or components. If you try to do that, and then you'd have like a entire brain of trivia. So, and I'm not going to ask you on the final exam, what is the, how many elements are there? How do you populate a table view with elements from a string? You know, actually, I'd have to sit and think about it for a few minutes, and I have to go, wait a minute, I have this, I've done this before, wait a minute, and recall how to do it. That's what you're going to do. So, alright, so the last step is to make sure that we're using the correct nib type for the project type. So select viewcontroller.xib file, and then view the properties in the attribute inspector. Change the class, the third icon from the left, to the UI view, from UI view to UI table view. So let me go in here and actually take a look here. Click on the XIB file. And if I look at the class, I see UI view. So if I run this sucker right now, I didn't change it, by the way, it's going to compile just fine. In fact, it's going to say 0 errors. I'm going to go, build successful. And then it's going to load on up. And then it's going to go, wrong nib. Eventually, it's actually trying to load. Whoops. This will actually stay up too. It'll be a little black screen. Then we have this core dump that occurs when it figures out, I'm trying to load the nib, I'm trying to load the nib. Can't load the nib. And it's still running actually, so let me stop it. Then down here in the bottom, you can see the kind of the interesting error message that's going to show up, and it's going to say, terminating at due to uncaught exception, NS internal inconsistency exception reason, UI table view controller load view loaded the view controller nib, but didn't get a UI table view. I can't tell you how many times I've had assignments sent to me and I go, oh, that's the first thing I check. Did they change the controller type so they're inheriting from a different, and then did they change the nib to match the new inherited controller type? Which usually is the problem. So I'm going back over here, I'm going to fix the problem, and I'm going to fix the problem by changing the view. So here we have our window, and I'm up here where it says the class up here. I'm going to change it to UI table view controller. Oops, not cell. Table view. UI table view, not cell. Now when I run it, Xcode wants to dispute me further. I'm going to have a problem. I may not have I don't have internet access. That is the problem. Alright, this relies upon internet access. Let me get internet access first. I lost my internet access. Okay, let me try this one more time. Let me make sure I have internet access first of all. Okay, I do. Make sure you have internet access when you run this, otherwise it's going to pull in nothing. Then you're going to see a blank screen. Oops, it was running. There we go. Now that I have internet access, I can actually pull the data from the internet. So you see that I only have the number of rows for the number of items. Now you can't see, but there's lines in here. But because I have this background here, actually, let me stop this here for a second. Change the background to white. Oops, attribute inspector might help. Let's see. We'll put it on white, and then we'll run it again. You can change the properties of that. You can put anything you want inside of those little cells. Or actually, I should say elements. What do we have inside the elements? We have an HTML element. We have an instance of an HTML object inside of each one of these. Oops. Maybe I have it turned off. Actually, I can sort of see it. What I was looking for were the lines. I have to change the attribute. By default, it appears that they are taken out. But you can actually stick the lines in so you can see the table view with the lines that are going in here. And that's just another attribute that you're setting on the table view. So we can do a lot more to this. We could put an icon over here. We could put a picture in here. These are instances of HTML elements that are in here. HTML has two components. It has the tag and the value. Here's the tag, here's the value. Now you can kind of see that this is the title and this is the detail. By default, it's in different fonts and different size. This is bold, this is not bold. These are the default settings of the table view. This can be customized completely. You can also, do other things with this. What can you do with this? You can go out to a website, maybe pick up text messages, chat messages or something, parse them, stick them in the table view. It looks like a chat system, and then maybe put something on the bottom here that says new, and then send, and send it up, and then bring it back. Because this is coming from a website. As you saw before, when I didn't have internet access, the website didn't pull anything. That's one of the problems of using a website in your app. But long story short, this is the completed app. Hopefully yours is working. So, and it demonstrates basically using objects along with other objects. So if you haven't noticed, for the Objective-C course, I'm picking projects that have more programming associated with them, more object-associated stuff. Next week, for the Objective-C class, we are going to look at Model View Controller a little bit more, and look at some more serious writing of code, actually. Not so much playing around with it, but because now at the point you're hopefully familiar with the tool set, you're not going to be battling with what we're doing. So we'll be writing some objects and looking at the views and looking at the controllers and all the different types. And so it's more what I might call we're getting into the more advanced kind of stuff. So past the beginner steps. So I believe we've done enough for today. It's 5:11. I think we can end. Unless we have questions? No? Okay, you guys are still with me. That's good. Some of you are still alive. Some of you are still awake. Alright, so I'm going to end this video.